You use HashMap 100 times a day. But ask yourself, could you explain, in detail, what fires on a single map.put? Most engineers cannot. After this video, you can. How HashMap works internally, in Java. Today, we crack it open. Let's start with what HashMap actually is. It's built on a hash table, an array of buckets, plus a hash function that decides which bucket each key belongs in. That's the whole idea, in one sentence. Think of a library with 16 shelves. You want to file a new book. You don't search every shelf. You compute a shelf number directly from the book's title. Same logic here. HashMap has an array of 16 slots. The key's hashCode picks the slot. Constant time access, no scanning. Internally, HashMap is just an array. Default capacity, 16. Each slot holds either null or a pointer to a node. That node is the head of a linked list. One slot, one list. Simple structure, surprisingly powerful. Every entry in a HashMap lives inside a node. 4 fields: hash, the cached hashCode, key, value, and next, a pointer to the next node in the same bucket. That next pointer is what lets a single bucket hold many entries. Putting a key-value pair, 4 steps. 1. Compute hash equals key.hashCode. 2. Compute index, n-1, bit and hash. 3. If the bucket at that index is empty, drop in a new node. 4. If not, walk the chain. Equal key, overwrite the value. New key, appended to the end. Worked example. Capacity 16. We put 6 entries. A through F. Each key's hashCode gives an index. A hashes to 65, index 2. B to 66, index 5. C to 67, also index 2, same as A, D and E both land at 5. F at 8, 3 indices but 6 entries. That is a collision. 2 different keys land in the same bucket. HashMap does not panic. It chains. The bucket's first node points to the second. The second points to the third. Each node carries its own key and value. Equals tells them apart at lookup time. Quick aside. Why n-1, bit and hash, instead of hash modulo n? Because bit and is one CPU instruction. Modulo is many. The trick, Java guarantees capacity is always a power of 2. And when n is a power of 2, both formulas return exactly the same number. Speed for free. Getting a value out, 4 moves. 1. Hash the key. 2. Compute the index. 3. Jump to that bucket. 4. Walk the chain, comparing each node's key with the equals method. First match wins. No match, return null. Look up the key, see its hashCode is 67. Index, 67-bit and 15, equals 2. Jump to bucket 2. The chain there is a then C equals says C is not A. Walk next. Equals says C equals C. Return 300. Done. Remove works the same way until you find the node. Then, unlink it from the linked list. Whatever pointed to it now points to whatever came after it. And if the chain ends up empty, the bucket itself goes back to null. Now the magic moment. Resize. HashMap watches its size. The instant size exceeds capacity times the load factor, 0.75 by default, it stops everything. Doubles the capacity. And rehashes every single existing entry into the new, larger array. Capacity 4. We've inserted 4 keys. A, B, C, D. Size hits 4. Threshold was 3. We resize. New capacity, 8. Now for every existing key, we recompute n-1, bit and hash. With n equal to 8, the indices may change. Each key gets re-bucketed. Resize is the one expensive moment in HashMap's life. It costs O of n, every entry has to be re-bucketed. But here's the thing. You only pay it about log-based 2 of n times across the entire life of the map. Spread out, that is amortized O of 1. The headline numbers. Average case. put, get, remove, all run in constant time. Worst case, O of n. That happens only if every key happens to collide into the same bucket. Which is why good hashCode functions matter. A bad hashCode means a quadratic disaster. Java 8 added a clever fix. When a single bucket's chain grows past 8 entries, and overall capacity is at least 64, that bucket converts itself from a linked list into a red-black tree. Worst case lookup in that bucket drops from O of n down to O of log n. Adversarial inputs cannot kill your performance anymore. 3 traps that bite engineers in production. 1. Mutable keys. Mutate a key after inserting it and its hashcode changes. You can never find it again. 2. The hashcode equals contract. If 2 keys are equal, their hashcodes must be equal. Break this rule, and HashMap silently misbehaves. 3. HashMap is not thread safe. For shared maps, use concurrent HashMap. 3 questions interviewers love about HashMap. 1. Why is put O of 1 on average, but O of n in the worst case? 2. What is a hash collision, and how does Java resolve one? 3. When does a HashMap resize, and what's the cost when it happens? You can answer all 3 now. Quick recap. HashMap is an array of buckets. The key's hashcode picks the bucket. Collisions chain through node next pointers. At 75% full, the map resizes and rehashes. Past 8 entries in a single bucket, Java 8 Treeify it. Average case, constant time. Next time you write map.put, you know exactly what fires under the hood. Subscribe for more Java internals like this one. And tell me in the comments, which JDK class should I open up next? ArrayList? Concurrent HashMap? You decide.